Hi, welcome to ToddFun.com, where I do what I think is fun. Today's fun is going to be called, the episode is going to be kind of called, Will I Fix It? And it's a laptop. It's broken, doesn't work anymore. It's a Dell 15-inch Inspiron 5521. So what's wrong with it? Well, some little munchkin of some friend of a friend dumped their Kool-Aid in it. But that usually means it's over. Usually means it's gone, because it's going to go down through the keyboard and it's going to probably overpower some power regulation part of the circuit, and it's going to blow it. So they said it was on when this happened, of course, and they tried to turn it on again. Of course, it was even worse. So they brought it over, and well, okay, let's go to the bench and see what we can learn about it. I don't want to turn it on until I've made sure it's clean inside, and then we'll see if will I fix it. To the bench. So I've staged a little bit of the disassembly to make it go quicker. You start by taking, on this particular one, you take off this panel, and then when that's off, there's some memory modules here you can pull out if you want to make sure they're kept aside. Then the hard drive has two screws here. It pulls out, actually it pushes back and then lifts up with this little tab. There's a little clear plastic tab, and it's a little tight fit, but it'll pull up, and you're basically just pulling on this tab to do that. And that makes sure that that's all released. Then you take out your battery first. Actually, there's just two clips right here. You pull them out, take the battery off, make sure it's unplugged. That, of course, is first step. Then you want to take off all the screws that are on here. They're going to be here, 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 here. Nothing underneath these little buttons. And when you take off this middle one, then your DVD-ROM will pull out. So then that's out of the way. That pretty much finishes the disassembly on the bottom. Then for the keyboard, it can be a little tricky. You want to make sure you get one of these iFixit spudgers. I got mine at Adafruit. I'll put a link in the show notes to help you out there. But there's little clips, and you want to get this down in there good and just kind of really get it down in there good and carefully just wiggle it around. And then you'll pop all those loose and they'll stay up, and then you wiggle around this edge and they'll pop up. Don't do the bottom on these Dells, because once you've gone around and you've got that to lift, and this is a bit more difficult when there's Kool-Aid sticking it down like glue, you peel it back a little bit and then you push that way. And there's hinges down here that only come out if you slide it out like a key. So it's kind of tricky. It slides this way. Make sure you go this way. Then you'll lift it, and then there's a little ribbon here. You just lift the tab. There's a little gray tab, lift it, and this ribbon will pull out. So that's how you get the keyboard off. Then there's going to be some more ribbons here. You lift the tab and pull this out. I like to use a little tweezers, and you just grab the tweezers, lift the tab, and pull it back. And there's one here and one here. Now you want to take out the screws that are in here. And there's going to be screws like here, here, here. They're all labeled. They're labeled like so they're all millimeter twos, but they're either 3-inch or 5-inch. So you don't even have to keep track of them. They're already labeled. There's one hidden underneath this cable over here, so you got to make sure you get that. And once all those screws are out, then everything that's screwing this thing together is removed. Then the real challenge of getting a spudger in here and working carefully along this edge, get it down in there deep, and you snap them. You'll start getting them to snap. Work around the edges, do the two sides, then do the front, and then come around the back, and then behind this little bump right here where the battery kind of goes in, there'll be some more spudging to do. You'll spudge your way around that edge down there. Once you got all that going, this is going to lift out, and the motherboard will be under it. So you expose your motherboard. At this point, there's one screw you can take off for your Wi-Fi card. That comes aside. Then you pull out the power for the motherboard. You pull out the video card from the motherboard. There'll be a screw over in this area right here, and I think that's the only other screw that holds this motherboard down at this stage. There is one of these ribbons you got to flip up. Like I said, you got to flip up that little plastic holder, grab it with the tweezers, and pull out this. This is for, I think, a USB over here. Then then pop out this. This is for your two speakers that are in the front on the bottom. These two bottom speakers. So you unplug that. Don't forget to hook those all up when you're going back. Then the motherboard lifts out of here. And what I'm looking at here is, where's all that Kool-Aid at? Well, yeah, I'll show you where I did find some. There was some Kool-Aid under the keyboard here, but it really wasn't a lot. And then there was some on top of the DVD-ROM right here. You can kind of see where the spillage is there. So that's where the damage would be if I were to see any. Or of course, you could short out something down here and then take out the power supply regulation over here, which could have happened. We don't know. So let's take a look at that. We're going to look for suspect areas. First of all, it's just a little bit of Kool-Aid got spilled, and the first suspect area is where was the Kool-Aid spilled? Well, we know it was spilled up in this area on the keyboard and came down in this area. So that's the first suspect area. The second suspect area, when you have this type of a damage, is here's where the power comes in from the battery, and likewise at the same point, that's where the power comes in from the AC mains. They're both coming in right here, which means your power regulation is going to happen right here. And in this area, you could easily have some damage from overloading. Something over here could overload because it shorts out something, and then your damage is over here where your power first comes in. But first and foremost, let's look in this area. And I didn't have to look far. I didn't even have to get my inspection microscope out because I could see the damage, or at least the visual damage. That doesn't mean something else isn't damaged, but the visual damage. Let's do the macro zoom on that so you can take a look with me. Well, there's what I'm looking at. In telezoom like this, it's hard to hold the board steady. This camera has a lot of nice tricks up its sleeve. But you can see those two look like some traces burned right there. And this is where some of that schmutz was that's built on the keyboard. And if it destroyed anything in the layers of the board, this may be, maybe a 6 or 12 layer board. And if it overcurrented and burned these traces, we can only hope they stopped here and didn't go internal to the board. Without an electronic schematic of this, I wouldn't know where to jumper to. If they're damaged here. Not to mention these could be damaged, or maybe they're not. Maybe the short is just right straight through the wiring and didn't damage these two transistors. This is QV7 and QV3. What I'll do now is I'll try and figure out exactly what those readings are. 6C something, and that's 6C something. So they might be exactly the same two. So a trick you can use sometime is that they like to use the same transistors wherever possible on the same motherboard so that the loading of the pick and place machine can have less reels. And so if you look around, if you can't read one, if you find one that has almost the same markings that aren't blurred out and has a good clear print on it, and you can realize quite quickly that it's the same one. So this is a 6C with a colon at the bottom, 2 colons over here, and then a 1. And this is where the display hook's in right here. So what they're really reporting is it doesn't power on. What it might be is these chips most likely control the backlight. And so I went and looked up. I went to ToddFun.com, and I have a thing called For Beginners. So in the menu, go to For Beginners, scroll down a little bit, and you'll see where I have links to surface mount identifying sheets. The first one I have there was S manuals. It's a link there under Beginners at ToddFun. And you then select laptops, and they have the Dell, they have this model, and they have the schematic, the circuit schematic. So then I just looked up the two positions, QV7 and QV3, and lo and behold, QV7 is LCD backlight. So a little bit of goop dropped right down the keyboard, got on those, shorted them out, either ruined the traces or ruined the transistors themselves. And this one is, of course, controlling the power source on going through, and this is essentially the on signal. This is the gate. This is the drain and the source. And the other one that we were looking at was LCD power control as well. That's here. This is QV3, similar LCD, the VDD, the voltage DD. They give you the exact part number they're using. They couldn't make it any simpler. Thank you very much for s-manuals.com. So get that. I'll put the link in the show notes too. So in case you don't want to go to Beginners at ToddFun. I don't know why I call it Beginners. I got lots of advanced stuff under Beginners, but Hey, what on? And so this is the chip. It's a 60 volt with a 310 milliamp. It's N channel. It's a pretty powerful MOSFET, and it's got some more specs, and it's got a couple Zeners built into it, and it's got a reverse diode on it. So there's some stuff in this thing that's probably not going to be in just a general transistor. Though a general transistor I might be able to get it to work and get it to fire up. Pushing the 60 volt limit and stuff like that. You know, this is actually made for automotive applications, but they're using it for the backlight, so that makes sense. What I'm going to do now is I'm going to get in there real close with my microscope, my rework microscope, and I'm going to clean up the traces, and I'm going to test to see if these transistors work. I scraped away all that corrosion looking stuff, and I made sure these traces were still connected here, and any other traces were still connected. And everything's trace-wise seemed fine, and I don't see the ass end of these blowing out at all. And there was a lot of corrosion on these two solder points, and now they clearly were rounded. They didn't have anything soldered to them, but they were corroded. What that means is most likely the Kool-Aid was conducting through here, allowing high current, causing the quick corrosion of those solder points. But that would have been coming down to QV4. So now I suspect QV4 might be damaged in that it might have been providing plenty of power to here until it finally just gave out. So I expect this guy. So I looked up the data sheet on this, and this is a P channel MOSFET. So I'm going to do some more tests. I'm going to do some tests of these transistors. Now you can't always test transistors in circuit, of course. Sometimes you can look at the schematic and decide if you can or can't. So let's look at the schematic real quick. This is the this is the QV4. It's a similar looking transistor data sheet wise, but it's a P channel. And yeah, I pulled the data sheet on that, and it's an A03419, the 20 volt P channel. And like the other one, it has some Zeners in here. Like this has some Zeners in here, and then a freewheeling diode. This has some Zeners and a freewheeling diode. And ultimately, it's difficult to test MOSFETs like this. But another little trick up my sleeve for doing in-circuit stuff is one of these guys, which is this is one of those transistor testers which you can get off of eBay. They're usually like 15, 20 bucks. And they normally have a socket right here. Well, I got a couple of these, so I took the socket off of one so I could put some flying leads on 1, 2, and 3. They're marked on the board actually. And when you push the button, it'll run a test for you. So I'll put a link to the show notes where you can get these on Amazon. Actually, they're already in my Amazon store. For the 3 leads, I take a couple of really sharp multimeter probes. They're not plugged into any multimeters. And then I clip onto them. I could put needles on here too if I wanted to, but this just makes it easier to probe because then I can hold 2 probes with one hand. And what I'll do is I'll get 2 probes on the gate and the source, making this gate and this source, and then the drain will be a 3rd one. And yeah, you'll see me do it, and then I'll click the test button here with one of my fingers. Got 2 probes on. I'm going to put the 3rd probe on with this dental pick. I'm pretty sure I'm on all the pins. Yeah, there we go. And it shows exactly what it should. And it's an N-channel MOSFET. So that one's definitely good. Okay, we're testing QE4 with the 3 probes now. And it shows a diode. Now I've repeated this test several times, and I always get the same result with that QE4. By the way, it doesn't matter which legs you put these probes on. This thing just figures it out for you and tells you which leg is what anyway. That was being stressed. And this one's most likely bad. I will pull them out and test them on the bench. So there's the 2 transistors that we need to test out of circuit. I'm pretty sure they're still going to fail. And there's a pencil tip for comparison, so you can imagine that's smaller than a normal pencil tip you would write with. Now this transistor tester does have surface mount testing pads. We can get it on the testing pads as long as the legs are long enough, and we can apply a little pressure and then hit the test. So I guess you don't need to see that, you want to see this. What will the screen say? It hopefully says the same thing, unless the circuit was causing us headaches. And I got that touching all 3 test pads, and away it goes. Oh, it's good. So we were fooled. In circuit just didn't succeed for us. Likewise, let's see if we can do this one. Might be too small though. It may not be on the pads, but oh, and that's good too. So in circuit they did not test. Out of circuit they test just fine. We got to put those back in, and I don't think there's anything else wrong. Maybe the corrosion was just getting it to where the display couldn't turn on, and now that I've cleaned up the corrosion, maybe if I put the laptop back together, it'll just power up. And if not, then we'll do some other troubleshooting where there's voltage tests and stuff to see if certain voltages are getting to certain parts of the circuit, but that's really hard to do with a laptop, because the laptop is, you don't have a test bed for a laptop. You pretty much have to put it together to test it. So it's tough to do those tests sometimes. Well, I got her partially assembled, didn't put all the screws in, but we got it together enough to do a boot test to see where we're at in the cycle. And lo and behold, what we got, we actually have text on the screen now. Previously we had just a black screen. It was absolutely nothing. So this is an improvement, but as you can see, it says no boot device. Now that means it can't see the hard drive. So okay, great. We have to deal with another problem. The display is working great now. It wants to come to life, but it doesn't have a boot device. So it doesn't sound like the hard drive is spinning up, but the light for the hard drive does flash. In other words, the processor is trying to tell the drive to, hey, I need you. So that's a good piece of health. I have another bootable. This actually came out of my other Toshiba. It is a bootable OS, and it wouldn't fire this up either. I was using it as an external, and I did plug it in to see if I could boot it off of USB. So this is the USB adapter I have, and I tried to see if I could just boot it off of the USB port. And there's no USB power either. So there's no power to the hard drive. There's no power to USB. And pressing a key to continue, of course, from here, keyboard doesn't work. And I switched out the keyboard. I switched out this keyboard with another Dell. I have another Dell keyboard just like it, and I know it's functional. And that keyboard doesn't work in here, yet this keyboard works in the other Dell. So the keyboard is fine. So we have problems throughout. We have voltage problems throughout. Well, our biggest goal was to just take this thing apart and make sure there was no fluid in it, nothing else that was going to damage it when we did do this test. So we did make ground. We do have a display. We know it's clean. At least we can move forward.
Well, the answer to will he fix it is he will not, at least not today. That's as most as I'm going to get done with it right now. We definitely have a voltage problem. I know the keyboard's 5 volts and probably USB is going to be 5 volts, so maybe the 5-volt rail is gone for those components. It's going to be difficult to test because even though I found really good schematics at s-manuals.com, I'll put a link in the show notes again, for this very laptop, there's voltages, and so if I know what voltages to look for, but there's no test points anywhere on this motherboard, and I combed it over pretty good. There's only way to know whether or not you got voltages at certain sections is to reverse engineer the power regulation circuits of this motherboard. They weren't kind, and they didn't put test points in there saying, here's your 5-volt rail, here's your whatever, and that makes it a lot easier to pinpoint exactly at what point are you losing a power rail. And it could be something that tells something to come alive. It might even be could be a simple transistor, it could be a proprietary component that's not sending out a signal. We won't know unless I look at this again. And I don't know if I will because it's a cheap laptop. It was already given a death sentence. The person's basically like, throw it away, use it for parts. if nothing can happen. But maybe still a good tutorial on how to approach the power rails. I'm going to have to reverse engineer those circuits a little bit, find those points, and then go from there. So if there is a part 2, I will try and put a link to it. Maybe I can even put an annotation right here, points to it. If not, then in the show notes, I'll put a link to a follow-up video if there ever is one. And it'll just be, can he fix it part 2 for the Dell Inspiron that we have here. So thanks for joining. Hope you learned a little something, and see you in the next vid.